Okay, thanks. Um, yeah, so I posted the link to this collab sheet we'll be working on today in the chat, and I want all of you to, I guess, open it and work along with me in a new copy. So I guess let's start off with a brief recap of what you already know. Uh, so you already know about lists in Python, and you already know about for loops. And if so, if you're not familiar with any of these concepts, like either the list or the for loop or anything I mentioned, please flag me in the chat before I go much further. So yeah, I'm assuming that you've all already learned about lists and for loops. So let's try to implement some functions which operate on lists. So so one common operation which we often do on lists is to find is to compute numerical statistics on them. So for example, that would include something like, sum, average, and variance, etc. So let's start off with implementing I guess a simple-ish function called list sum, and we wanted to return the sum of all the elements in the list. So for example, if we run list sum of A, it should be 7, 9, 10. So this should be 10. So yeah, so all of you create a new Google Colab worksheet and start trying to implement this function. And yeah, let me know if you get stuck, and comment on the chat if you're done. Yeah, it looks like a couple of you have gotten it, and so I'm gonna move on. But if you are stuck, don't hesitate to stop me in the chat. Like, it looks like there's only about 20 members on today, so we should be able to address any specific issues which you're having. All right, so yeah, the implementation of this list sum can be done in multiple ways. I'm not going to go into that because it's pretty straightforward. But I do want to point out that there is already an inbuilt method and an inbuilt function in Python called sum, which does something very similar to what we tried to implement. So in a lot of cases, there's going to be an inbuilt Python function for the most common operations, but in case they don't exist, it's generally good practice to to move any repeated computation to a function, like any code which you think might be reused in multiple places should ideally live in a function. So yeah, let's move on to the next exercise. And yeah, this next exercise is just to is just to mix the for loop and if loop. So this function prints small elements is supposed to take a list and an integer, and then it should print out every element of the list which is smaller than the second argument. Okay, yeah, so I'm not seeing any dones in the chat right now. So I'm assuming that you're all stuck on this. So does does anyone wanna mention in the chat what you have tried or where you're stuck? Okay, so let me walk you through how I would solve this, and maybe that will unblock you. So it's generally really helpful to just break the problem into smaller problems. So the overall thing which we're trying to do is to print every element which is less than I. So that's two separate problems. One problem is to print every element, and the second one is the less than I part. So we should all already know how to do the first part pretty simply. Yes, so what I've implemented now is just printing every element of the list, which is pretty straightforward. And now let's add on the second part of it, which is the less than I part. So yeah, so all we need to do is to add that conditional here. So yeah, so now instead of printing every single element in the list, we'll only print when it satisfies that condition. And yeah, and so that's pretty much it, and that works. So are all of you clear with what's happening in this function right now? Okay, awesome. Yeah, so let's move on. So uh I want to talk about another data structure. So far the data structures which you guys know are strings, which is strings are strings and they're defined inside quotes. And you also know about integers, which is a number. And there's also floating point, which is very similar to an integer, except that it has a decimal point. And finally, we've also worked with lists. And yeah, and these are pretty basic and important data structures which you'll be using in a lot of places. And another very important data structure is called a dictionary, and it allows us to store actually let me just give you an example instead of before defining it. All right, so firstly I'm going to define a dictionary named X. And the key thing to notice here is that I'm using different kinds of braces as opposed to the list. For a list, we'll use square braces to define it, but for a dictionary, we use curly braces. And in a list, we can only store things sequentially. So, for example, right now we have a of 0, a of 1, so on and so forth. But a dictionary allows you to store things with arbitrary keys. So now what I've done here is uh, what we have here on the left hand side, this is called the key. And the key is basically something like its index. It's the identifier which we use to represent this particular data. And in this case, bar is the value, and the value is the specific data which we're storing in this dictionary. And so now let's print out this dictionary and see what it looks like. So yeah, so now when we print out this dictionary, we can see that it has one value in it, which is keyed at foo. And now let's try storing more information into this dictionary. So yeah, I'm just going to store it in a key called key2. And yeah, now we can see that this dictionary actually has two values in it. And uh, another thing which might not be immediately obvious is that a key uniquely identifies, specific information. So it's not possible to have different data with the same key. So what that means is that if I reuse an old key and put a different value in it, it's going to override the data which used to exist in it before. So now I stored the value 1000 into the key foo, and it overrode the previous value bar. And uh, it's possible to examine this object like you could examine a list. So some examples of how you could examine it is length to start with. This tells you the length of the dictionary or how many keys you've stored in it. And you can also iterate through this dictionary using the for loop. So if you iterate through the dictionary like you iterate through a list, yeah, so if you do for x in the dictionary, it's going to iterate through the keys by default. So suppose you wanted to print out the dictionary in a different way. You could do something like yeah, so here here I'm iterating through the dictionary, and then I'm printing out the key and the value. And I'm finding its value by looking in the dictionary and using the variable k to index the dictionary. So this is slightly different from the way which we've been doing things so far, which is mostly using constants as an index for the list. So I just want to point out that it doesn't need to be a constant. We can use a variable, we can use a function, or basically any expression which returns which returns a valid key would work here. And the another way to iterate over this dictionary is so so if you iterate over x dot items instead of just x, it's going to iterate over both the key and the value. And uh, yeah, so I guess let's try to build something with a dictionary right now. Okay, so for the first exercise, I'm just going to define a constant dictionary. So I'm defining a dictionary called scores, which we'll use to and let's put some data into this dictionary. Okay, so now we have three values stored inside this dictionary. So let's write a function which does some computations on it. So let's for the first exercise, so this this function is supposed to take a dictionary of scores and actually let's make this never mind. All right, so yeah, this function should so this function should look at all the scores in the in the given dictionary and find its average and print that out. So yeah, I want you all to, I guess, attempt solving this exercise. Yeah, and one more thing. So uh, one way to solve this is pretty similar to how you solve the first exercise, which was list sum, but uh, that would be a little tedious. So let's use this hint. So if we want just the values of a dictionary, we can use the so if we use the values method on a dictionary, it will return just the values and not the keys. So since for this case we don't care about the keys, which is the name of the student, we can just operate on this list. And yeah, and the next thing is, I mean, if you're stuck, like, just remember that average just means sum divided by number of elements, and we know how to do both. So we know how to find the sum of all the elements in the list by using this sum function, and we know how to find the number of elements in the dictionary by using this len function. So we just need to combine these two functions inside this print test average function to solve this. Yeah, so how are you all doing on the print test average function? So yeah, to the student who said it's not working, like, could you expand on that? Like, maybe, post the error message in the chat, or just like try to put it into words which part you're stuck on. And yeah, there's only 23 students, so you can all use the chat. I mean, you can all use the voice chat. All right, so I'm gonna rename this. Never mind. So passing an argument to the function is pretty similar to what we've seen before. So I'm all right. So firstly, we've defined this dictionary called test scores. So this variable's name is test scores, and it's a dictionary, and it has 3 values in it. And now we have defined this function called print test average, which takes one argument called scores. So if we call print test average with this dictionary, which we've already defined, this test scores is going to become scores when Python evaluates inside this function. So remember that we want to pass a dictionary to this function. So you shouldn't be changing the type of the argument before sending it to the function. So this is how you would call it. So yeah, to start off with, I'm gonna take what we talked about here and create a list of all the scores. And so now if we run the function, we can see that it's receiving a dictionary as an argument, and then it's creating a list from that dictionary, and then it's printing that list. And if we want the average score, yeah, all we need to do is find the sum of that list and then divide it by the length of that list. So, and also, by the way, there is a never mind, it's not in the standard library, the function for mean. So does everyone sort of understand what's happening inside this print test average function? All right, so in that case, let's move on to the next exercise, which is more of a, I guess, a standard iteration. So what we want to do is we want to find out uh, the names of all the students who have passed this test. And a student has passed a test if their score is greater than 50. So for example, if we call this function with test scores, it should print out Ram and Sita, and it should ignore Champu because their score is under 45. And uh, if you, yeah, just look at the examples of how we used a for loop on a dictionary for a hint on how to solve this problem. So, you can basically just mix this pattern with how we applied if conditionals on lists. Yep. So yeah, the question is the last cell in the sheet, which is we want to implement a function which takes the test scores dictionary as an argument and then prints out the names of all the students who passed the test. And a student has passed the test if their score is greater than 50. Yeah, and if you're stuck or like it's not immediately obvious how you would solve this, just remember to to break down the problem into the obvious parts. So, firstly, like this function should print the names of blah, blah, blah. So you can start off with the function just printing all the names and then add on the past condition to that. Oh, yeah, sorry about that. So yeah, I was saying that I wanted to point out that I used different variable names in this for loop. So in the previous example, I'd used for k comma v, and k comma v is just shorthand for key and value. And in reality, you can use any variable name here; they will all work. So, for example, I can make this for x and y, and that would be valid too. And it's generally good practice to use descriptive names. So here I'm using name and score instead of key and value. So I'm iterating through the items of the dictionary and printing out the name and the score. And this prints out everybody's name and their corresponding score. And so this is the first part of it, which is the printing out everybody's scores. And then the second part of the question was to print out the names of only the students who have passed the test. So that's again pretty similar to what we've done before. And we add this conditional here. So now instead of printing out everybody's name and score, we're only printing out the name and score if the score is greater than 50. So does that make sense? All right. So yeah, and the final part was this function was just supposed to print out their names and not the scores. So we just removed this. Okay. So yeah, there's a good question in the chat, which is how did test scores become scores? And I guess let's revisit functions really quick. So the way in which we define a function is we first use the keyword def and then the name of the function, and then the names of the arguments separated by commas. So this function's name is function name, and it takes two arguments, and the names of the arguments are argument 1 and argument 2. And this is the definition of the function. But while we're using the function, we can basically send anything to it. So for example, I can call this function by passing constants directly, and that would work. And I can pass in the name of a variable. So I'm going to say x equals 5, and now I can pass in x here instead of a constant. And how this actually gets evaluated is that when Python tries to run this line of code, it first sees the name of the function, so it knows where it needs to go. And then it sees that you've passed in arguments. And since this argument is not a constant, it goes to its definition and sees what you have defined it as and then replaces it with its value. And then the next argument is a constant, so it gets passed on directly. So it doesn't matter what their names are when you're calling the function. The names here mean something only inside of this function. So for example, if I try to print out argument 1 outside of the function, we're going to get an error because the name argument 1 is not defined outside of the function. Argument 1 exists only inside of this function. Yeah, so I hope that clarifies things. All right, so, and one last thing, it looks like we've only got about 5 minutes or so left, is that in general, it's not very useful to have a function just print things out. It's more useful to have it return things, because then we can reuse them, because if it just prints something, it's not possible to mix this function with something else. So for example, if we wanted to return a list of all the names which have passed, what we can do is we can create a new list inside of this function. So firstly, I'm creating an empty list called past students. And instead of printing the name, I'm going to put the name inside that list. And finally, once we're outside of that for loop and we're done iterating through that dictionary, we can return that list. And so now if we run this function, we're actually going to have a list. So we can, for example, assign it to something else. So now I've assigned the return value of this function, which is a list, to this variable. And if we look inside of this variable, so if we look at the type of this variable, we can see that it's a list now. And we can use this variable in any function which operates on lists. So append is a method which exists for lists. So I'm creating a new list called new list. And because the type of this is list, because the type of this variable is list, there are some inbuilt methods it already has. So Yeah, so there's a bunch of these. You can see all of them if you just type dot, and uh, you can look at the Python documentation to see what it means. And append is the method which we're using. So if we append 5 and then look at new list, we can see that it has 5 inside of it. And similarly, we can append another element inside of it. So the list started out empty, and after we appended 5 inside of this list, it had 1 element inside of it, and then we appended 10 inside of it, so now we have 2 elements in it. All right, so yeah, it looks like we are out of time. So on Saturday we'll dig deeper into how to return more meaningful things and how to I guess simplify our loops. And yeah, in the meanwhile, like if you have time before that, like I'd recommend you guys uh go through the book and also the Python documentation and just play around with uh with functions and lists and dictionaries. It helps to write a bunch of code and just see what happens, uh, as opposed to just passively observing it. All right, thanks everyone.
Thank you, sir.